expressions of summation n factorial 2 raised to n divided by n raised to n. We have general nth term of the series given by un equals n factorial into 2 raised to n divided by n raised to n. We will obtain un plus 1 by just replacing every n in this expression by n plus 1. Now we take the ratio un by un plus 1. We group the terms which have similar fashion. N factorial of un and n plus 1 factorial of un plus 1 are of same fashion, so it has been grouped. 2 raised to n of un and 2 raised to n plus 1 of un plus 1 are of same fashion, therefore they have been grouped. Now n plus 1 the whole raised to n plus 1 of un plus 1 and n raised to n of un are of same fashion. Since un plus 1 appears in the denominator, for the ratio un by un plus 1, n plus 1 the whole raised to n plus 1 will appear in the numerator and n raised to n will appear in the denominator. We can rewrite n plus 1 the whole raised to n plus 1 using exponential law as n plus 1 the whole raised to n into n plus 1. N plus 1 the whole raised to n plus 1 can be replaced as n plus 1 the whole raised to n into n plus 1. So we have grouped all the terms which have similar fashion. Now we can write n factorial is the product of n terms ranging from 1, that is 1 into 2 into 3 into etc. n gives us n factorial. Similarly, n plus 1 factorial is obtained by taking the product 1 into 2 into 3 into 4 into etc. n into n plus 1. So in n plus 1 factorial, n factorial is also present. N plus 1 factorial can be rewritten as n factorial into n plus 1, or we have n plus 1 factorial written as product of n terms ranging from 1 to which we multiply n plus 1th term. Therefore, we can cancel these n factorials. Similarly, this n plus 1 and the n plus 1 which was left out after cancelling n factorial of n plus 1 factorial can also be cancelled. Now, using the exponential law, we have 2 raised to n plus 1 written as 2 raised to n into 2 raised to n. We can cancel 2 raised to n and 2 raised to n from numerator and denominator. So, finally, we are left out with the terms n plus 1 by n the whole raised to n and 1 by 2. If we divide numerator and denominator of this expression by n, we obtain 1 plus 1 by n divided by n the whole raised to n into 1 by 2. When we apply the limit to this expression, we have 1 by 2 is a constant and we have the standard limit. Limit n tends to infinity, 1 plus 1 by n the whole raised to n equals e. Therefore, this expression after application of limit becomes e and 1 by 2 is written as it is. When e by 2 is greater than 1, as per ratio test we have the given series is convergent, and it does satisfy the condition that e is greater than 2 because the value of e is greater than 2. Since the limiting value satisfied the condition, limiting value is greater than 1 everywhere, therefore we have the given series is convergent.